Hey guys, this week we're going to do this lesson a little bit different, and if we have issues with it, then we will fix it afterwards, okay? So your lesson is going to be online. Please have your books next to you. Please have your calculator next to you, a piece of paper, your notebook, however you do this to learn. We are going to pause through the lesson as is we would do for review, and I'll have you work some problems and come back, restart the video, and see if you got the right answers, okay? Um, I'm traveling on Tuesday, so this is the Tuesday class for all of you because I won't be here, okay? We are starting in 11.3, which is on page 677, and we talk about, you can't read it, but if you have your book, you can read it, perimeters and areas of similar figures. And to recap really fast, we did similar triangles before. This is not a new notion for you. And similarity meant that if you have two figures are similar, the ratio of the smallest side to the bigger side will always be the same. That was similarity. Similarity meant that, I'm going to write it really fast here, AB over its corresponding WX will equal to BC over its corresponding XY will equal to CD over the corresponding YZ. And the last one, it's going to be AD over the corresponding WZ. And they're all going to be the same ratio. We've done this in triangles. It stays the same for any type of polygon, right? So it's the same similarity. So if I look at these two different polygons that I just drew, I kind of got them from the book, but then I gave them values just to remind you how it works. There's the first one, there's the second one. And I am telling you that these two quadrilaterals, four sides, are similar. That means the ratio or the ratio of similarity is going to be AB, which is 3, over WX, which is 6, or 1/2. And this is the similarity in between the two figures. We know that the rate of similarity is going to be 1/2. Well, what happens to perimeters? Because that's what we're studying today, perimeters and areas. For perimeters, we already learned in the triangles that the similarity rate stays the same. So it would be easy for me to say it's literally 1/2. But let's see why. Well, what is the perimeter of the first smaller shape? I have 3 plus 2 is 5, plus 4 is 9, plus 2.5, I get 11.5. Let's see what is the perimeter of the big one. Remember, perimeter, we add all the sides. 6 plus 4, 10, plus 8, 18, plus 5, 23. What do you notice? 11.5 is the half of 23. We can reduce this to 1/2. This is why for perimeter, if you have the similarity rate because you have the two sides, then automatically that moves to perimeter. Okay, it's going to be the same way. With the area, it changes a little bit. It's going to be your first side squared over your corresponding side squared also. So instead of being just 3 over 6, it's going to be 3 squared over 6 squared, or 9 over 36, and this reduces to 1 over 4. We always reduce, right? We never leave a fraction not reduced. If you notice, it's 1/2 squared. I just wanted you to know that it's always going to be the initial ratio that you have here, and it's going to be squared in both places. That's kind of how it works. Let's look at example 1 in the book so you can see physically what that means. And I ask you to keep your book next by so you can follow through. It says, the pentagons ABCDE and LMNPQ are similar. Find the ratio red to blue, so we know red on top, blue on the bottom, of the perimeters of the pentagon. Well, let's see first, do we know the ratios of red to blue? Yes, we know. We know that DE has a corresponding side, which is PQ, and DE is 5 and PQ is 10. We always reduce this rate of similarity is 1/2, right? Well, if I have the rate of my sides, that means the perimeter of the ABCDE over the perimeter of, I don't remember where they started, LM and PQ will be the exact same thing. We just copy what this is. The perimeter is the same ratio as the sides. Nothing changes, okay? Now on part B, it says, find the ratio, red to blue again, of the area of the pentagon. So I need the area of A, B, C, D, E over the area of L, M, N, P, Q. And I can do it two ways. I can take the sides and square them and then reduce, or I can just use the reduced fraction. You can do it either way you want. You can just go 5 squared over 10 squared, so you can follow the rule. 25 over 100, this reduces to 1 over 4. If you ever worry about reducing, please remember you can go 24 divided by 100, you're going to get 0.25. A math fraction, enter, enter, and you get 1/4. So if you have the similarity statement, the perimeter will be the exact same similarity statement. The area will be that similarity statement squared. Let's see how you do. We're going to try this. I'm going to let you go to page 679. And I need you to work 4. And I need you to work 5. 4 and 5 is what you're working. When you come back, I would say pause right now. When you come back, I just need you to go ahead and look at the board and follow with me and see if we got the right answers. However, please read ratio what color to what color. Don't just assume it's always going small to big. You need to know, is it red to blue, blue to red, how it goes, okay? Pause your video, 4 and 5, restart. Okay, guys, here's 4. I'm going to move out of the shade. They give us 2 hexagons. We're going red to blue at all times. Smaller side is 3, that's the red. 9 is the blue. When you reduce, this is 1/3. Which means for perimeter, I have the ratio of 1/3. For area, you can either just could have gone 1/3 squared, which is 1/9, or you could go 3 squared over 9 squared, which is 9 over 81. You reduce that to 1/9. For 5, and I think I'm going to bring this a little bit closer because I have the space. For 5, we're still going red to blue. You're going to notice that the big number is on top because red is the bigger figure, 6 over 4. That reduces to 3 over 2. For perimeter, my ratio is the same, 3 over 2. Nothing changes. For area, you can either go 3 over 2 squared, which is going to be 9 over 4, or if you just want to keep it the way, because you know the sides, you're just going to go 6 squared over 4 squared. 36 over 16. They both reduce by 4, or if you do this in a calculator, that's going to reduce it to you to 9 over 4. So perimeter, same as your side, similarity rate from the sides. Area, it's going to be that to the second power. Okay, that's what we do. We're going to move to 678 and work the last of this lesson, which really stays the same. We're not learning anything new in 11.3. Okay, I need this to focus back on me. We did it. In example 2, it talks about a photograph, and it says, you are buying photographic paper to print a photo in different sizes. You get an 8 by 10 size, and it's going to cost you, for one 8 by 10, you're going to pay $0.42. Okay, that's how much you're going to pay for one sheet of paper like that. What is a reasonable cost for a 16 by 20? So for 8 by 10, you paid this much. Let's reduce that fraction first. 8 over 10 becomes 4 over 5. Correct? We're going to look at the next one, and we're going to look at, let me look at this and see what happens here. Let's look at 16 over to make sure that these are similar. 16 over 20, you reduce this by 4, you get 4 over 5. So they are the exact same size, right? They're the exact same size. However, I don't know how much bigger one is than the other, but when I put 8 over 10 and 16 over 20, I'm going to notice that to get to this number, I doubled the size of this picture. Basically, I made it double, right? 8 times 2 will give me 16. 10 times 2 will give me 20. I doubled the length, and I doubled the width, and I doubled the length, which means really the ratio to one to another, when it comes just to the length, if you think about, this is the photo. Let me draw it. And this is not a good drawing, but this is 8, this is 10. this is 16 and this is 20, my similarity statement is 8 over 16, which is 1/2, or I can do 10 over 20, which is also 1/2. This is the smaller, this is the larger. Okay, well, if I got this, and I know that for one of these little ones, I pay $0.42. In order to know how much I pay for this one, you're gonna be like, I'm gonna double it. No, because we're not paying for the perimeter. We're printing the whole picture, which means we need the area, right? So for the area of the small over the area of the large picture, I'm gonna get 1/2 all squared, or 1/4. So as much as you pay for one of the smaller pictures, you're gonna pay 4 times more for the area of the larger picture. The other way to do it would have been to just really check what's the area of the smaller. 8 times 10, that's 80, right? We pay, that's 80, that's the area. What's 16 times 20? I have no clue, but I'm gonna do it in my head. It's 320. Yeah, it is 1/4 when we reduce it, right? If I just put area over area. So that means if I pay 42 cents, not $0.42. If I pay 42 cents for the smaller print, I'm going to pay 4 times more for the largest print. So for this one, it's going to be 4 times 0.42, which is 8, 6, 1. $1.68 we're going to pay for the largest print. Remember, in order to figure out this type of problem, you just simply need the area. And here's why. Think it through. Because when you print the picture, you don't just print the size. This would be the perimeter. Your picture is the entire thing, so represents the area. So what we needed to find is the ratio, then square to find what is the ratio of the two areas, and we figure out if you pay this much for one small one, you're going to pay 4 times more for the largest print. We're going to look at the last example, and then you get to do an example on your own. It's example 3. Let me erase this really fast. I am trying to speak super, like, not fast, so we follow through. It says, find perimeters area of similar polygons. We're staying over there, same thing. And we're talking about an octagon. And dear Lord, there's no way that I'm going to draw 2 octagons for you because I can't do it. Okay, I'm going to try it. It's going to be terrible. Okay, this is not that bad. I mean, it is bad, but it's not that bad. Let's do a bigger one. Okay, more or less. I know they're not similar, but we're going to pretend, okay? And they name them, believe it or not. They start in the top and they go A. Wait, the smaller one is here. A, B, C, D, E, F, G, H. I wish Mateo would have been here. He would have sent to you. The other one started JK. J, K, L, M, N, O, P, and Q. And here's what we know about these 2 octagons. We know that the one octagon, the bigger octagon, has a size of 14.25. 14.25. The other information that I have is that the smaller octagon, this one, the perimeter of A, B, C, D, E, F, G, H is 76. I already know the perimeter of that one is 76. They're asking to find the area of the smaller octagon that has this perimeter. So we do know the area of the bigger one. The area of the bigger one is 980.4. Did I just flip them? No. Okay, in order to find any similarity of the area, we're going to have to find the similarity of the perimeter first, right? Because we know that if we have that, then we're good to go and square it and find that area ratio. There's two ways to do it. Okay, this is easy. One, if you notice, for one, they give you the perimeter. I know the perimeter of this one is 76. For the bigger one, just they give me one side. So there's two ways to go of this. Either, this is an octagon, you go what, 76 divided by 8, and that's going to give you 12. And that would give me my my smaller side, and now I can find that similarity rate. Or you can go the perimeter of smaller, I'm just going to do this, perimeter of smaller octagon over the perimeter of the larger octagon are this. The perimeter of the smaller one is 76. The perimeter of the largest one is 8 times 14.25. Why? Because it's a regular octagon. It has 8 sides. To find the perimeter, I had to either times it by 8 or add it 8 times, right? If I do this math really fast, I end up with 76 over 114. When you reduce this baby, you get 2 over 3. Okay, this gets reduced by 38 apparently. Yeah, 38 goes into both of them. But again, if you get to this, remember, 76 divided by 114, you're going to get decimal, math, fraction, enter, 2 over 3. Now that I know this, I can say the area of the smaller octagon over the area of the larger octagon, it's going to be 2 squared over 3 squared, or 4 over 9, which is great. Why? Because I already have the area of the larger octagon. So if I rewrite this and I go the area of the smaller octagon over the area of the larger octagon, which is 980.4, has to equal what? 4 over 9. I know exactly what it's going to be. This becomes a proportion. We've done proportions a lot. At this point, you're going to cross multiply. 9 times the area of the smaller octagon is going to be 4 times 980.4. Please do not attempt this without a calculator. Divide by 9. You're going to put all of this in the calculator, and the area of the smaller octagon is going to be 435.7. You can go ahead and check it. If you want to pause your video right now, do the math and see if you get this. They rounded to 1 decimal, so make sure you round correctly. So how did we solve this particular problem? They gave us the perimeter of one of them. They gave us the side of the other one of them. And then you're going to have to figure it out. What is the area? So the first thing we wanted to know was the similarity rate between the perimeters. I had one perimeter given to me, 76. The other one was easy to find, and that is because this is a regular octagon, which means all I had to do is take this measurement and times it by 8, because there's 8 sides in the octagon. I did this division, I got 2 over 3. When I got to this number, then I know that to find the similarity rate between areas, all I have to do is take the original similarity rate and square it. It became 4 over 9. And then I could write that as a proportion. The area of a smaller one, that's what I'm looking for, over the area of the larger one that's given to us will equal exactly what we found out, 4 over 9. This is cross multiplying. 9 times what we need to find out, the area of the smaller one will equal 4 times 980.4. We're going to divide the 9 out, use a calculator, and we found out the area of the smaller octagon. I'm going to let you take a second, and I'm going to let you work 679, problem 6. So please remember that we did on problem, you're pulling off example 2 that had to do, don't pause yet, please do not pause yet, that deals with, you are going to print an 8 by 10. So here's what we have, an 8 by 10. And for one print, we're paying $0.42 or 42 cents to keep it like that. In this case, they want to know what is the reasonable price if you're going to print a 4 by 5. Please remember, you're still going from left to right. Your similarity rates will still go from here to here. I'm going to let you pause right now, try and solve it, come back and let's check. Okay, so this is what we know. We're going from an 8 by 10 to a 4 by 5. The ratio still goes left to right. So your ratio right now is 8 over 4 or 2 over 1. We're going to need to deal with area. Again, this is a picture. You print the entire area, right? The area of a larger print, 8 by 10, over the area of a smaller print, 4 by 5, it's going to be 2 squared over 1 squared, or 4 over 1, which means if you pay 42 cents for the larger print, you're going to pay 4 times less to get a smaller print, right? You're going to pay less for a smaller print, or 0.42 divided by 4, which is 0.1. I think it's 0.10 cents. My book says 0.11, but I don't understand how it is unless I got the wrong price in here. About 10 cents, 11 cents, but over there. Okay, so again, the only thing that mattered here is where you're going from left to right, to know to write your proportions correctly. And then to be able to remember, in order to get this out, you need the area because we're printing the whole picture, right? And in this case, this one is definitely going to cost more than a smaller one. Our purpose is to see how much less this will cost. And when we end up with 4 over 1, that means this is only 1/4 of what the bigger one is worth, okay? And this is where we stop for 11.3. We're going to continue with 11.4. Okay, guys, here goes 11.4, circumference and arc length. We're staying within the circle. And we have talked up until now about perimeter, because that was the way we calculated the distance around the shape that was made by lines. When it comes to a circle, the circle does not have a perimeter. It has what we call a circumference. It means the exact same thing. It means that if I start here, I want to know exactly how long it is to go around the circle. It's really the same thing, that concept of the perimeter, but this is round. You can't do it because you don't have from here you're 3 and from here you're 5, and it's curved, all of it, right? And so the formula for circumference, it should go on your cheat sheet that we said we're going to do for this chapter, is either 2 times pi times r, or remember, 2 radiuses make 1 diameter, or diameter times pi, or pi times diameter. This will be your best friend always, because pi is 3.14 and it's going to be crazy. And I would rather you use the actual pi. If you need to know where it is going to be your second, and it's going to go on top of your little hat right there. Let me see how I can do it to where it focuses. Any minute now. Your pi, please focus, will be, it's the number right on top of your little hat right in here, okay? So that's second, and then you hit that little hat. I'm sorry, I couldn't get it to focus. Okay, let's look at example 1. That's the easiest probably of the lessons today. It says, find the circumference of a circle with a radius of 6 centimeters. And that's going to do first. What is the circumference of a circle that has a radius of 6 centimeters? Well, that's just your formula. The circumference is going to be 2 times pi times 6, 12 pi, or I'm not even sure they're going to leave it there. They're not. This is where you get your calculator on, and you're going to do 12 times second little hat. You're going to see a pi there. 37.7 is the circumference of that circle. Really, it's just calculator work knowing your formula. On part B, it says find the radius of a circle. What is the radius if the circumference of the circle is 31 meters? The circumference is 31 meters. I know that already. Well, here's my formula. Circumference is 2 times pi times r. I'm going to plug in everything that I know. I know that this is 31 equals 2 pi r. Remember, pi looks funky, but it's a number. So all I need to do is divide by 2 pi. I need to get rid of it. 2 pi. So my radius is 31 divided by, make sure you use parentheses when you do this in your calculator, please. Parentheses 2, second little hat, close your parentheses. It's going to look kind of like this. I'm hoping it's going to eventually focus for you. Here it is. It was focusing a second ago. You can kind of see it maybe. Not really. But anyways, that's what it is. It's 4.9. The radius is 4.9 or about 5 if we're going to round, okay? It's very hard for me to determine how many decimals we're going to keep. I'm just staying safe for 4.9. We're always going to keep 1 decimal. That was our rule at whole time. So this is kind of how you find circumferences. I'm trying to see if they give you any examples on this. No, they don't give you any work. So we're going to move directly to your second thing of today. And that is, I'm going to put the circumference over here, 2 pi r, or pi times the diameter. And if you remember, in last chapter, the one that you just had a test of, we have talked about the measure of an arc. We've done arc measurements over and over and over again, and they were always in degrees because we said we don't care how much you travel from here to here. We just want to know what is the opening of that angle. We are now moving to a new concept, arc length, which means literally if I am on point A and I want to get to point B, how many feet, how many miles, how many yards am I going to have to walk? So it's a physical measurement that deals with measurement units and not with degrees, okay? And the formula for an arc that you have, it's always going to be this. The measurement of, well, the length of AB. If you notice, I almost write M and then I have to take it off. The length, the walking length of this is going to be, we're going to use from chapter 10, the actual measurement of AB, which is going to be degrees, divided by 360 times the circumference of the circle, 2 pi r. Please don't panic about this. Most of this information will be given to you. But this is why I'm saying this needs to be on your cheat sheet, okay? The length from here to here is found by finding what is the actual degree measurement of this arc divided by how much does the circle have as degrees, 360, times the circumference of that circle. So let's look at physical problems that deal with this. This is not going to be hard to work on. We're going to look at the next page. Let me erase this and work some examples and see how we do. Then you get to do it on your own. In example 2, it says find arc length. Here's what you have. You have a circle, and I'm going to try to draw them all neatly. I have a radius of 5, and I am told that this angle over here is 50 degrees. Here's my arc. I want to find what is the length of AB. Okay? Let's plug everything that we know and see if we know all of the information that we need. The length of FB is going to be the measurement of AB divided by 360 times 2 pi r. Let's replace everything that we know. Do we know the actual degree measurement of this one? Yes, we do, from chapter 10. We know that because this is a inscribed arc, it's going to be the exact same measurement of its angle. If it would have been over here, we would have had to divide it by 2. But because it starts a second, it's exactly the same measurement of the angle. So this becomes 50 divided by 360 times 2 pi. And what is my radius? 5. Please don't do this by hand ever. This is a calculator work. You're going to go and you're going to say 50 divided by 360, enter, times 2 times pi times 5. It's going to be 4.36 centimeters. So you're going to do this division, then you're going to times it by 2 times pi times r and get the number out. That's why I'm saying while it seems hard, all of this information is given to you. All you have to do is replace everything you knew. You knew this much. You knew what the radius is. Everything is numbers. We plug it in, you get it out. Let's look at example B. Let me erase this. I'm going to leave the formula on because we need it. I'm going to just draw this part that it's come from here. It goes here and here. This is 7. This is named CD. The angle is still 50, believe it or not. Okay, what is the length of CD? Well, it's the same thing. The measurement of CD divided by 360 times 2 pi r. Nothing changes. So this is a central angle, which means the arc is the same as the angle. 50 divided by 360 times 2 times pi times 7. Again, absolutely calculator. 50 divided by 360 equals times 2 times pi times 7. 6.11. That's what I get when I round. 6.11 centimeters. Is that what we're working on? Again, all we need to know is plug in the information. On part 3, let's see what we get. Let me erase this, or see on example 2. Again, I have a circle. My radius is 7. My angle is now 120 degrees. That's where I am. And this is called EF. Again, the length of EF is going to be the measurement of EF as degrees divided by 360 times 2 times pi times r. Or, again, central angle, which means the arc has the same measurement as the angle, 120 divided by 360 times 2 times pi times 7. Let's go ahead and do it. 120 divided by 360 times 2 times pi times 7. 14 points. Wait, no. Oh, I did the division wrong. I'm sorry. This is not good. Here we go. 100, is it 120? No, it's 100. That's why I got the wrong number. Sorry. 100, guys. 100 divided by 360 times 2 times pi times 7. 12.22 centimeters. I think these type of problems are easy because all of this information is given to you. All you have to do is plug it in correctly and then figure out how to work it. Let's look at example 3 because it stays in the same thing. We're using the same formula, but now they're giving us different information and it's asking something different from us. On example 1, it says find the in an example A on 3. Find the circumference, which remember the circumference is 2 pi r, correct? This is what we're looking for. And here's what we do have. We have a circle that has a center of this. It has a central angle of 60 degrees. And the arc measurement from P to Q, not measurement but length, is 3.82. And that is meters. Here's how you know this is not measurement but length. It's not degrees, it's meters. That means we walk it. You can't walk 35 degrees. You can walk 3.82 meters. So this is my arc length. I know my length. Let's try the formula again. The length of PQ is going to be the measurement of PQ all over 360 times 2 pi r. What do you notice? 2 pi r is the circumference. I can take this out and say this is going to be times my circumference. That's what I'm looking for. Let's replace everything that we know. Do I know my length? Yes. 3.82 needs to equal 60 over 360 times C. I'm solving for C. My first move will be to reduce this. This is very reducible. This is 1 over 6. And I need the space, so I'm going to erase it. How do I get rid of 1/6 to just get C? Times 6 over 1 times 6 over 1. This goes away. My circumference is 6 times 3.82, which is 22.92. There's no way for you in this type of problems to get an answer without a decimal. And that is because you will constantly work with pi, which is an irrational number, which means it has a decimal that never ends. So just know there's no way to go around this, okay? We have to have decimals. This is why I say you need this. Let's look at part B. In part B of this example, and if you need to rewatch this, pause it, rewind, watch it again. In part B, here I go. I have a circle again. What a surprise. I have an angle, X, Z, and Y. They're giving me the radius. The radius is 6.64, 7.64. I know what the radius is, meters, inches, sorry. And not only that, they give me the length of this arc. And here's how I know this is the length of this arc and not the measurement, because it's 18 inches. I mean, there's not a lot to walk on 18 inches, but again, we can walk 18 inches on my tippy toes, right? So what do they want from us? They want the measurement of the XY as an arc, which means we're going to end up with degrees. Well, let's find the formula for it. The length of XY, I need some space. The length of XY will equal the measurement of XY, this is exactly what we're looking for, over 360 degrees times 2 times pi times my radius, which is 7.64. I'm going to go ahead and change colors really fast so that you will know this is what I'm looking for. The measurement of x, y. That's what we're looking for. What's in green, that's what we're looking for. Let's go ahead and do all the math that we can. Do we know this length, by the way? Yes, we do. This is 18. I can go ahead and replace it. Well, the first thing I want to do is time all of that together. I get 2 times pi times 7.64. That is 48. You cannot round it any better. So please rewrite this if you need to. I will do it. 18 equals the measurement of XY over 360 times 48. Okay, the first thing I want to get rid of is 360. I want to get rid of 48 over 360, so I'm going to times it by 360 over 48. Why? Because this will go away with this. This will go away with this. Times 360 over 48. We're going to do that math and see what we get. 360 times 18 divided by 48. I end up with 135. The measurement of XY is 135 degrees. So why did I time it by 36 over 48? Because this is a 48 over 1, right? I need to get rid of it. I'm going to times by the reciprocal. The reciprocal of 48 over 360, it's 360 over 48. I can reduce all of this, finish my math, and that measurement of that angle is 135 degrees. You have all of that answer also on the bottom of page 684. I am going to pause now. I need you to go to page 686, and I need you to work 3 to 8, all of them. You have to match A, B, C, D, E, and E. 3 to 8. It's a matching game. You have to match which one goes with which one. I'm going to let you pause right now, and then when you're done, start it, and let's see how you got it. Okay, guys, let's go ahead and see what you did in here. The measurement of QR. It's a central angle. It's going to be 120 degrees. It should have gone to F. The diameter, if the radius is 5, diameter is double, the radius 10. It's going to go to D. So this is F. This is D. We're going to skip the length because we're going to work all of them. We're going to go to circumference. Circumference is 2 pi r. 2 times 5, 10 pi. Do we have a 10 pi? Yes, we do. This is B. It goes over here. So now we're left with a few fractions and answers that we need to work on. Let's work one by one. The length of QR, we're going to do 7 first. Length of QR. It's going to be the measurement of QR over 360 degrees times 2 times pi times 5. Or 120 over 360. We already know that. Why? We solved it in the first one times 10 pi. Well, 120 over 360 reduces to 1/3. I need this space. I'm going to write this as 1/3. Or I can write this as 10 pi over 3. There it is, 10 pi over 3. For this one, I have A. Let's go ahead and find the length of the other arc now. If we're going around, there's an S over here, and they want to know what is the length of this part. Well, if that center angle is 120, what am I left with? 240, correct? So I can use the same thing, except that I'm going to say here QSR this time. Instead of that, I am going, instead of 1/3, I'm going to put 240 over 360. And if you reduce this in your calculator, or you just know how to reduce it, this becomes 2/3. This becomes 2 over 3. Or 20 pi over 3. Why? Because I can put the 10 pi over 1 and we times across, right? 20 pi over 3 is the length of QSR. What did we do? Well, if this angle is 120, then the bigger angle has to be 240, right? Because together they're 360. So now becomes 240 over 360. Reducing that gives us 2/3 times 10 pi. And you don't have to do the math on it. It's just 20 pi over 3. In case you actually did the math, which really will not help you in here, go ahead and check what 20 pi over 3 is. It's the same answer as you, and you can pick it. So 20 pi, this would be C. And I don't even have to work anymore because I know the only one I didn't use for here is E, length of a semicircle. But let's see it for the sake of it. What is the length of a semicircle? We don't have a semicircle here, but the length of a semicircle is going to be the measurement of a semicircle. How much is that? 180. Divided by 360 times 2 times pi times 5, because that's my radius, right? 180 over 360 gives me 1/2. This 2 goes away with that 2. We can get rid of it. The length of a semicircle in our case, we're going to be 5 pi, which is great because this is exactly what E is. So this is how they worked. The only one that probably should have given you any trouble would have been the 240. And that we found that by subtracting 120 from 360, then just literally applying the thing. In this case, because you see the pi's as answers, you're not even supposed to solve them. You just have to keep it as it is and see which one matches which one. Okay, we're about to finish this lesson. Together, we are going to go ahead and move into the second goal of this class, which is comparing circumferences. And this is one of the lessons that I'm not the biggest fan of. You need to understand this. I always hated the revolution problems. I have never been incredibly good at that, but we're going to work on it and see how they work. Let's go ahead and read example 4 together. Tires from 2 different automobiles are shown below. How many revolutions does each tire make while traveling 100 feet? Round decimal answers to 1 decimal place. So basically they're saying if a wheel is traveling on the road 100 feet, how many times does it spin during that 100 feet? So the first thing we want to do is find the circumference for the 2 wheels. And I'm not going to draw them this time because I don't have the space. But the circumference of wheel A is going to be 2 pi r, or the diameter times pi. Let's see the information we have on this one. Well, we have that the diameter of the, I forget what the name of the silver thing is 14. It's going to be 2. No, not 2. We're going to have pi times 14 plus 2 times the actual tire, 5.1. Right? The diameter of this wheel, I'm going to have to draw it for you, is this 14 that we have here, plus 5.1 here, and plus another 5.1 here, plus basically 10.2. This is what this becomes to, 10.2. So this is pi times 24.2, which gives us, I will just go with the book because they tell me what it is 76.03. That is the diameter of the first tire. Let's see what we have for the second tire. I'm going to erase this really fast to find the circumference of the tire B. Again, it's going to be diameter times pi because that's what we're working on. Here's what it tells me. For the second wheel, I have a 15 diameter inside, and then I have a 5.25 on outside on both places. So this becomes pi times my whole diameter is going to be 15 plus 2 times 5.25. Okay? 2 times 5.25 gives me 10.5. Or this becomes pi times 25.5. We're going to put that in a calculator. They did it for us because we like them, and it is 80.11. So that's the circumference of each wheel. We now need to know how many times do they go in 100 feet. The first thing I want you to notice is that we have absolutely two different measurements. So if I want to know how many rotation for tire A, I'm going to have to go 100 feet over 76.03 inches. And I cannot do it this way. Believe it or not, this is not the way to go. I need to have the exact same measurement. Because why? I need to go how many times does this little circumference go into this measurement? Well, 100 feet, there's 12 inches in a foot, correct? Yes. So that becomes 1,200 inches divided by 76.03 inches. I can now go ahead and do that division because I have the exact same measurement. 1,200 divided by 76.03, 15.78 revolutions. Let's look for tire B. It's going to work the exact same way. We have 100 feet. And the circumference, one rotation of our wheel has 80.11 inches. We have the exact same problem. We cannot do feet and inches together. We have to convert the feet into inches. That's 1,200 inches over 80.11. Here it is, 1,200 divided by 80.11. I did not do it correctly. It is 14.97 or about 15 revolutions. Okay? That's where we are to find revolutions. So in order to find out how many revolution in any rotation problem, you need to know two things. One, what's the circumference of each wheel, of each bearing, of anything that's round? You need that circumference. Then you need to find out how many times that circumference fits into the distance that your circle travels, and you need to make sure that the two units are exactly the same. Otherwise, it's not going to work out, okay? We need to convert and make sure we know what we're doing. Okay, this is the last problem we're going to look at before I let you go. It is an example 5, and it's called finding the arc. It says the track shown has 6 lanes. Each lane is 1.25 meter wide. There is an 180 arc at each end of the track. The radii for arcs in the first 2 lanes are given. Okay, find the distance around lane 1. So let's look at that track. The distance around lane 1. I do have my first radii. My first radii is R1. That's for my lane 1. I need to find the distance. The distance is going to be first the circumference, the 2 ends, 2 pi r, times 2 times the sides that you're running. If you think of a tracking thing, right? This part drawn correctly with this part drawn correctly form a circle. That's my 2 pi r. I don't know why this is capitalized. And then I need the 2 s's, the 2 lengths that I go on the straight part of the thing, plus 2 times s. Well, we have all of that information for us. It tells us that the s is 108.9, so I get 2 times pi times my first radius, which is 29. This is a plus, not a times, I'm sorry. Plus 2 times s, which also it's a decimal, 106.9. If I'm seeing correctly, because it's super late and I can't tell, 108, I'm sorry. And then you put that in your calculator, you end up with 400 meters. How did I get there? In order to find the distance around my lane 1, I need to remember the end two semicircles form a circle. So now I need to know the circumference of that circle, 2 pi r, and they gave me the radius. And then I need to add the 2 straight lines in our running thing, and we're good to go. Now, for the second part of this, it says, find the distance around lane 2. Again, you have your radius given to you. The distance for lane 2, this is L1. It's going to be 2 pi, my radius 2, plus 2 times S, right? Okay, let's find this one. This becomes 2 times pi times my second radius, which is 30.25, plus 2 times S stays the same, 108.9. And then when you put that in your calculator, that becomes 407.9 meters, which you could probably round to 408. Does this make sense how it went? I'm hoping it did. Okay, the last thing that you are going to do for me before I let you go, I need you to go to 686, and I need you to work problem 12 and 14. Please remember they're coming off the formula for the arc length. Once you work them out, please restart your video and let's see that you got your answers right. Okay, guys, this is it. We're going to finish within an hour of this lesson. For 12, the length of AB is going to be the measurement of AB divided by 360 times 2 times pi times r. We know the measurement of the arc because it's a center arc. It's going to be 140 divided by 360 times 2 times pi times 29.5. You put all that in your calculator, you should have gotten 72.08. If you didn't, pause the video right now, look at what's on the screen and figure out why. This is not very visible. I'm going to write it again. Times 2 times pi times 29.5, okay? Pause, see what the problem is. If not, let's move on to 14. In this case, they're asking us for the measurement of an arc. It's not hard. It's just knowing how to do pre-algebra, basically. The length of EF, which is given to us, will be the measurement, which I put in green, divided by 360 times 2 times pi times r. I'm going to replace everything that I know. What is my measurement? 67.6 needs to equal the length. 67.6 equals the measurement that I don't know over 360 times 2 times pi times 25. That's my radius. The first thing I did, I actually broke it in pieces for you, is I timed by 360 to get rid of it in both places. I ended up with 24,336 equals the measurement of EF times 50 pi. I'm going to keep it simple. And then I divide the 50 pi out because I just want the green stuff. If you did not get 154.9, please make sure, if you did this correctly up to this point, that the 50 pi in your calculator are in parentheses. Otherwise, you're going to get a different, your calculator is going to go this divided by 50, and then it's going to times the pi, unless you tell it all of it is to be divided. And you end up with 154.9. This is it. This is all the lesson for today. If you need to rewatch it, rewatch it. I am going to post your homework up. Any questions that you did not get, we're going to deal with it next class. So don't worry about it. If something doesn't make sense, just ask me. However, I am asking you to watch the video. I am asking you to do it with your book in front of you. And I am asking you to try your best to participate, even if it's a video class for this time. We don't do this normally, but this time we had to do it because I can't be there. So also, all of your test corrections are up. I linked the document that has all of your corrections under private comments under each of your name in Google Classroom. Please remember, if you want corrections to come in, you need to send them by the following class, which is in May, before we start class. So your corrections are due not today when you're watching the video, but a week from today. If I don't get them, your grade stays. If you're not pleased with your grade and you would rather retake the test, you can also do that. But again, I need your test before next Tuesday. If not, your grade stays the way it is. So this is it. I'm going to miss seeing you guys on Tuesday, but you guys are going to do great. Leave me any questions, anything. If I need to do a short video to add to this, I'll gladly do it, so that we can move on. And then I'll see you in about a week, I guess. I love y'all.